Hey everyone, welcome back to my channel. This is day 8 of the Redis 0 to Hero series. In this video, we are going to discuss Redis Set, which is one of the important data structures used in Redis. In this video, we will go through the social app, for example, LinkedIn, and we'll see how Redis can fit in features like finding likes on a post or which all users has liked the post, finding friends, finding mutual friends, finding online friends, finding followers and also who are following, and much more examples. Do watch this video till the end. You will take away something for sure because we will be discussing real world use cases and common patterns. And just a quick reminder, if you have not subscribed yet, I would recommend doing that. In this series, we are going to solve real world problems with Redis, step by step, just like it is done in production. So without wasting time, let's get started. What is set? A set is an unordered collection of unique items, right? It is similar to Java hash set. You can add an items into a set and later you can check whether the item is in the set or not and take some action accordingly. Okay, so why do we use set when there is already a list? List can also provide similar functionality, right? The first thing, set does not allow duplicate items, and also it can provide order of one constant time performance when you want to check something is present in the set or not. List in this case will be slow actually. Okay, now what are some of the use cases of Redis set? For example, in Slack, most of you guys have already used Slack, right? So in Slack, we show the current active users, right? So we can use Redis set for that purpose. For example, when user logs in into the Slack, we can add an entry into the set, and when user logs out, we can remove the user from the set, something like that. Also, let's take one more example. To maintain a block listed IP addresses, we can use set for that. So for example, microservice, whenever any request comes to that service will check whether the set contains the IP address of the request against the block listed IP addresses. If it is present, the microservice will not process the request, right? And there are further set operations, for example, union, intersection, difference. I will be demoing each and every functionality of this set in this video. So let's jump on to the demonstration. I will just open the Redis CLI first and let's practice few of the commands what are available in the Redis set, and then we can move to the IntelliJ IDE to do all the operations programmatically. Let's go to the Redis CLI. So what I'll do is I'll just check whether my container is up and running or not. So for the guys who are new onto this channel, so I have prepared a detailed video on Redis Docker setup. You can refer the day 2, right, where I have explained each and every step how we can install the Redis or set up the Redis. Now what I need to do, Redis CLI. Okay, let's do FlushDB first so that we can start from scratch. You already know what FlushDB does. Now, what all operations we would be performing onto the set. So first of all, we need to create the set. How we can create the set in Redis? All the set related commands will start with S in Redis. Okay, for example, if we want to add, then the command would be sadd, add into a set. And if you see, there is a key and the members. Now key is actually the set name. For example, the users. Now what all members are there? For example, user ID 1, user ID 2, user ID 3, user ID 4. Let's say these are the user IDs. You add into a user set. So if you enter, you get how many entries have been inserted or modified. So you get the 4. So that's how you will create the set. Right now, behind the scenes, the set is created. Now if you do keys star, the keys is there. The key is users. If you do the type, right, and do the users, you would see set. So implicitly the set has been created. Now what all operations you can do? How to check size of the set? So for that you have the S, since it's a set command, so that you can do the S card. So card here stands for a cardinality. So it means the cardinality of the set. So for example, S card users. Means there are 4 elements into the set. So S card give you how many unique items are there inside the set. Now how to see the members or items inside the set, right? So for that we have S and then we have the S members. So if you do users, you would see, okay, these are the members present inside the set. So what we have added, 1, 2, 3, 4. There are 4 items and these are the members. Now the point to note here is the order is not guaranteed here, but it does not allow duplicate. So for example, if you do S add and you do users and you do 4, so it would give you the output as 0. That means the element has not been inserted into this set. So it does not allow duplicates. Now one important functionality what we need in set. How to check whether an item is there in the set or not. This is very common operation, right? So for that, S is member. If you do S is member and do use users, for example 1, you would see that the output is 1. That means it is present inside the set. Similar to what you do if you do users 2, it would still give you the output as 1. That means the 1 means the item is there. So if you do, for example, S member users 100, right, it would give the output as 0. That means the user ID 100 is not there inside the set. Now how to remove an item from the set? You would start with S and then srem, right, and then you do users, and if you want to remove, for example, user ID 2, and you would see the output as 1. That means the item has been removed. So if you do again, you want to see the members, what all members are there, you can copy this command S member users. So if you do that, the 2 has not been there now, right? The 2 is deleted. Now even if you issue the command like S is member, right, and users, for example, what we have removed 2. Even if you do this command, this would give the output as 0, and this is very common operation used in most of the applications. Now there is one more command to remove the item from a set. So that command is spop. It actually removes the item randomly from the set. It can remove any item from the set. For example, spop users, right? So it would remove 3. So even if you do S members, so you would see the 3 is not there. So spop actually removes any of the item from the set randomly. Let's move further. Firstly, I'll clear the console. Let me clear that. Now let's discuss the real application use cases where Redis set related commands can fit. Now for example, let's take an example of LinkedIn, right? On a LinkedIn, there is a post. Now every post has likes. So we can very well fit Redis set there. How? So for example, if user likes the post, we can add the user ID into the set using the sadd command. So if user unlike the post, we can just use the srem command. And if we want to check whether the user has liked the post or not, we can make use of is member. And if we want to see how many users have liked the post, right, we can use of scard command, right? So for example, you can visualize this. This is a Redis set and this is the key, right? The key is like the post ID is 99 and every post has the likes, right? And these are the contents. We can quickly practice it one more time. So what we can do is sadd, for example, post 99 and then we do likes, right? We can add any member, user 1, user 7. Let's assume these are the user IDs, user 42, user 108. So these many members have liked the post, right? So if we want to see how many users have liked the post, what we can do is scard. We can see there are 4 users who have liked the post. Now let's assume after the like, user 42 unliked the post, right? So for that, what we can do is srem. If you see the scard again, you would see there are only 3 users who have liked the post, right? Similarly, if we want to see whether the user 42 has liked the post or not, so what we can do is S is member, right? S is member and we can pass the key and then we can pass the value. There is no post liked by user 42. Now similarly, if we want to see whether the user 7 has liked the post or not, we can see that this user has liked the post. Now when we click on the button like how many users or which all users have liked the post, so for that we can use the smembers command. If we do enter, we can see all the users who have liked the post. Now let's discuss few more use cases related to set. Right, so for example, if our use case is finding the friends plus finding the mutual friends, now for this we can make use of set related concepts. For example, we have in mathematics, we have studied the union, intersection, difference, matrix difference, right? We have studied all this. So let's revise that first and then we will come to this use case. So for example, in terms of set theory, we have these two sets. The A is one set, the B is one set, right? So if we want to find a union of A or B, what we can do is A or B. So it would be a complete set. So this would act as a union. Now if we want to find intersection, intersection means A and B. So if we have set A and B, so what would be the common part? This is the common part, right? So this is the intersection. Now if we want to find the difference with respect to A not B, then it would fall in this set. And if we want the symmetric difference, for example A not B and then B not A, then it would fall into this kind of case, right? Now with this understanding, let's discuss how we can fulfill this use case, right? So what we need to find the friends plus mutual friends. So in terms of Redis, we can think how the Redis model would look like. So in Redis, what we can do is we can create a user ID friends. This could be one key. Now whenever one user gets a friend of any user, what we can do is we can add an entry of that user ID into this set. So for example, this is the case, right? So for example, user ID 1 friends, and this is the values. So whenever these are the actual friends of that user ID 1, right? So whenever some user gets a friend, we can make an entry into this set, right? Now our requirement is to find the mutual friends. Now for example, let's say this is user ID 1 friend and this is user ID 2 friends. Now what we need to find? We need to find the mutual friends. What all mutual friends are there between user ID 1 and user ID 2. So for this, what we can do is we want A and B intersection, right? So we can simply make use of sinter command, right? So for example, sinter, what should be the value? The user ID 5 and user ID 8. These are the two users which are present in both the sets. So these are acting as a mutual friends, right? So I'll just demo that case quickly, right? So for example, we have add user 1 friends, right? And we can make an entry like user 3, user 5, right? These are the 4 friends of user ID 1, right? So similarly, what we can do is user, right? And what we can do is user 2. We can make an entry user 5, user 8, user 10, right? So these are the 3 friends of user ID 2, right? Now what we need to find? We need to find the S intersection, right? So what for that? The set related command starts with S. So sinter, and what we want to find? User ID 1 friends and then user ID 2 friends. We can see the user ID 5 and the user ID 8. So that's how we can make use of intersection. Now even if we want to find the union, give me all the friends of user ID 1 and user ID 2. Let's say this is the requirement hypothetically. So for that, what you can do is S union, right? And you can pass this, right? So if you do that, you can see the user ID 9, 5, 3, 10, 8. So it gives you all the user IDs which are present in either user ID 1 friends or user ID 2 friends. Now let's say our requirement is to find the mutual friends between user ID 1 and user ID 2, and let's say we want to store in a different set, right? So there is also a command for that. So for example, sinter store, right? And what we need to find? We need to give the destination set name where we want to actually copy that. So for example, the key could be user :1:2. Let's say this is the key, and we want to store the mutual friends. Let's say the mutual and let's say the friends. This is the key, right? And what we need to store, we want to find the mutual friends. So for that we want to give this, right? So this is the new set name, and these are the sets on which the intersection would be applied. So if you do that, integer is 2, so it means the two values have been added into this set, right? So if you want to do as members and we want to do this, you can see user ID 5 and user ID 8. Now let's say our requirement is to find the difference who are friends of only user ID 1, not user ID 2, let's say. So for that there is a command like sdiff, right? So what we can do is we can just give sdiff user ID 1 friend, and then we can give user ID 2 friends. So if you do this, we can see the only the user ID 1 friends are there, not the user ID 2, that is the user 9 and the user 3. So that's how actually we can make use of set related commands. Now let's discuss few more LinkedIn features where we can use Redis Set, right? So for example, if our requirement is to finding the online friends, right, how we can make use of Redis Set in this kind of feature, right? So as we earlier discussed, right, we do store the user ID friends in the Redis Set as in when the friend is there for a user, right? So we already have this kind of list. Whenever user logs into a LinkedIn and user is active for some time, so what you do is you make an entry into this set. So in terms of Redis, there are two sets. The first is user ID friends, right, and then is the online users, right? Now if we want to find who are the friends which are online, right, how we can do that? So we can just quickly apply the intersection, right, the intersection between this set and the intersection between this set. So what we will get is user ID 7 and user ID 10. So we have already demonstrated this kind of use case, right? So for example, I can just quickly mention that, right? Now our requirement is, for example, this is a add user 42 and there is a friends, right? And who are the friends? User ID 1, user ID 7, then user ID 9 and then user ID 10, right? So this is the user ID friends, user 42 friends. Now let's say we have the another set, the online friends. There we have the user ID 7, user ID 8, user ID 10. And if we want to find the online friends, how we can do that? We can just apply the intersection between this set and intersection between this set. So what we'll get is user ID 7 and user ID 10. So we can simply make use of an set intersection theory and we can get the online friends. Let's discuss few more examples how and where we can use the Redis. As I earlier mentioned, we can make use of Redis Set in case of blacklisting or whitelisting checks, right? So for example, there are some IP addresses which are blocked. Let's say in your organization there are some IP addresses which are blocked, right? So you can use Redis Set there, right? So we can maintain the blocked IPs set, and whenever the user or who wants to access that IP address, firstly what we'll do is we will check whether that IP is blocked or not. And how we can make use of sIsMember command, right? sIsMember, and then let's say this is the set, this is the value, right? And if it is a member of the set, it means this is blocked IP, right? So we cannot allow user to access that IP address. Now let's take one more example. On Uber, whenever you want to book the cab, you see the available drivers are there. So in that case also we can use the Redis Set. So for example, we have the available drivers as the Redis Set, as and when user request for a cab. So what we do is we can assign any random driver to the user request. So what we can make use of in that case, we can make use of swap command. So this is the use case where you can use swap command, and I have already demonstrated this command and how it works. There is one more use case where we can make use of Redis Set, that is rate limiting, and this is one of the very common feature where we use Redis Set very effectively, right? I can just demonstrate how it would be. So what is rate limiting? If we want to limit the user request per window, right? Let's say this is the case. On what basis we can limit the request? Either on the basis of IP or on the basis of user ID. Let's say in this case we are making use of an IP. How the model would look like? We can create a key like use IP with, for example, this is the IP address and these are the requests. So for this IP address, how many requests can be processed? Let's say only 30 requests can be processed in a 60 seconds. Right? So what we can do is we can just add the request ID as and when it comes into this key, right? So we add that request ID to this key and we apply the expiry as well onto this set, right? And before adding into the set or before proceeding the request, what we would do is we would check what is the size of this set. So if the size of the set is 30 or less than 30, that means the request can be processed. And if the size of this set is greater than 30, that means the limit has already been breached. We can't do anything, right? And if the set is not there, right, that means the window is over. In the next window, we can process the request. So we can make use of Redis Set in this case as well. So the guys who want to have more understanding about the rate limiting and how the rate limiting would be done, I have prepared a detailed video on rate limiting onto my channel. You can refer that. I will add that video onto the description, and also you would see the card popping up onto this video. So that's all I had planned for today. So if this video helped you, hit like, subscribe for the Redis series, share it across your team and drop a comment with your questions or use cases. I will see you in the next video. Thanks a lot for watching.